Hello and welcome to the latest webinar by BitGardener. My name is John Kowalski. I'm part of the marketing team here, and I'd like to welcome you. Today's program, Innovations in Production Dispersing and Milling, will take about 45 minutes today and hopefully have some time for some Q&A at the end. If you do have some questions, please log them in the chat box. It should be in the bottom right-hand corner of your screen, and we'll get to them. If we do run out of time, we'll make sure someone follows up with you directly after the presentation. Also, we are recording this, so immediately following the presentation, you'll receive an automated marketing link to that or to this recording that you can share with colleagues, watch later, take screenshots, whatever you need. Today's speaker, Director of VMA Getzmann, USA, Canada, and also BitGardener, Mr. Andy Stumer. Andy, how you doing today, sir?
I'm doing great. Thank you, John. Hello, everybody, and welcome to our series of dispersing presentations. And today we're going to talk about the innovations of production technology. And we're going to talk a bit about the different dispersers and also basket mill systems that are available for larger scale production. And with that, we go right into the next slide here. And here, it's actually a picture of the last European coding show. That was the VMA Getzmann booth, pretty big. And we'll be there again in the middle of March, so next month. The week of the 20th, I believe, is when the show is going to happen in Nuremberg. And we will have some of the production scale Dispermats. You can see a couple right there on the right-hand side of the picture. We will have them on display, and also the latest and greatest laboratory models that we offer, the new CV3 Evo that just came out, the new CN and AE lab scale dispersers, and the basket mills. We're going to have those on display. So if you're over there or have colleagues that work out of Europe, please feel free to stop by and drop in, and let's have a cup of coffee, and then I can give you guys a tour of what we have to offer. Okay, so basically, we're going to first do a brief introduction about VMA, the relationship with BIC. Then we're going to go briefly into a dispersion process overview. We're going to talk about the equipment side, and then finally, we close it off with the lab and pilot resources that we offer. We have a really nice lab up in Wallingford, Connecticut at BIC USA, so we're going to be talking about that and what capabilities we offer. Okay, so with that, we're gonna look at the founding members or founding couple of VMA, Mr. Hermann and Elke Getzmann. Back in 1972, they found this company, VMA Getzmann. Hermann is still coming into the office about once a week just to make sure that they still follow his design philosophy. And yeah, he's a pretty nice man, and he's sharp, and he still walks around the facility like the day when he opened up back in 1972. And down below is the first Dispermat that was introduced in 1973, and we still have some customers, actually I've visited them myself, that are still running with some original Dispermats. So the motor technology is really sound, and these units, they will last forever. So basically, the company has been growing quite a bit over the last almost 50 years, and they have now over 100 employees worldwide. They're still run by the same family, Martin and Christian Getzmann, the sons of Hermann and Elke, are the CEOs of the business, and VMA obviously is known as a high-end quality manufacturer of dissolvers, speed mills, basket mills, not only for your laboratory needs, but also for upscaling with to pilot as well as manufacturing facilities. So here is a good picture that kind of gives you an idea of the facility in Germany. So they're about 30 miles east of Cologne, is where they're located in a small town called Reichshof, Germany. And the building right in the middle is what was expanded. They added another floor, and the whole backside was added on for more production space. And they have a new design area where they have hired more design engineers. About 40% of everything that VMA builds today is custom. So there's a lot of new, what we call end use markets with different types of requirements, fuel cell and battery. They have very special needs. So VMA is on top of those requirements and needed more capabilities from a manufacturing standpoint and design standpoint. So they had to add that space to support these new growing markets. And then they also have a really good lab space in Germany and the pilot facility. So if you have colleagues over there that want to come in and visit VMA and run some trials, let us know and we can set that up. We have a number of people that come in every year, US colleagues that have businesses over in Europe and that would then take advantage of that lab capability. So with that, we're going to talk briefly about what we're trying to do with our equipment. So basically, the dispersion process is just very simple. All we're trying to do is break up binding forces that are holding these particles together. So on this picture, you can see basically these are pigment particles, and these primary particles are fused together by these invisible, they're called van der Waals forces. They're like these electromagnetic forces that bind these particles together and form these larger clusters called agglomerates. And by using dispersing technology and high shear, we're able to break up these binding forces and reduce the particles to smaller clusters called aggregates. We do that with the Cowles blade, an impeller blade. If we want to go from the aggregates down to the primary particle size, we still break up binding forces, but a Cowles blade is no longer efficient enough. So for that, we would need to do some sort of milling with the beads, and we're able to put in more energy, and that will allow us then to break up these binding forces and reduce these aggregates to primary particle size. Obviously, once you separate the particles, it's really important that we keep those particles in a suspended state, and that would require to use some type of additive to help us accomplish that. So our sister company, Big Additives, has a good selection of various additives for all the different markets like inks, coatings, just to name a few. And now, obviously, with batteries, Erin Kelly, if you know her, they can offer some really good solution to ensure that these particles then stay in a suspended state. So this kind of the same principle here, except here we're kind of showing you that with the technology. So first we have these larger clusters, these agglomerates. We are wetting them and pre-dispersing. So we're breaking up these forces with the blade. And then once we reach smaller aggregate size particle clusters is when we start the milling process. So here you can see this is a horizontal bead mill. You see the rotor right there on this picture. And basically, once we are done pre-dispersing, we would run it through the mill, and then we would be able to produce very small particles. In the case of a horizontal mill or a nano basket mill, particles as low as 100 nanometers and less with the right setup. And then again, stabilization of the particles is critical to ensure that they don't flock back together and form new clusters. Okay, it's just an example of different pigment types and different sizes under the microscope, giving you an idea what kind of that looks like. And then on this particular slide, it's very important to understand at what point we are moving from a dissolver that's basically just a Cowles blade or a high-speed mixer, some people refer to, over to a bead mill. Usually the threshold is about 10 to 30 microns, but that really depends on the formulation, on the type of product that you're making or formula, additives that go in there. So, but usually 10 to 30 microns is the threshold. and anything smaller requires some sort of bead milling. Obviously, there's different types of mills we're going to talk about today. So very well known, the horizontal mills, or some people used to still the 3-roll mills, sometimes used for reducing particle size. We have our business, we're very strong with the basket mill approach, or what some people refer to as immersion mills, for numerous advantages we're going to cover. And then there are also some type of vertical bead mills, like pot mills. They're referred to. They are more used for laboratory and small pilot because it's very difficult to scale them due to the volume of beads that you would need in a manufacturing environment. But you can see that if you have the right bead mill, you can get down very, very small in particle size. And we had some cases in automotive and battery applications where we are below 50 nanometers now. So it's pretty impressive. You need a lot of time and very, very small beads to get there, but it's definitely possible. So in a nutshell, so the dispersion process is always 2 parts, right? So we first pre-disperse by using a dissolver. And there we have for production the Dispermet SC we're going to cover. And then once we pre-dispersed and get to about 10 to 30 microns of particle sizes, when we do our fine grinding or milling or fine dispersing processes, where we have the different milling options. So we have our vertical bead mills, milling system called APS. We're going to talk about and show you a picture. That's more for lab and small pilot. Then we have the basket mill approach, which is really nicely scalable all the way from lab to pilot to manufacturing. Tourist mill SK, what the quick change system that we have, where you're able to go very quickly from a dissolver setup over to a basket mill setup, giving you the advantage of having one piece of equipment for both your pre-dispersing as well as your milling. And then horizontal bead mills are well known, and there we have the series RS, different chamber volumes depending on how much you want to make per hour. But these are the 3 different milling technologies that VMA offers, and that's what we're going to be talking about today. So here are just some different markets where it's used, mainly adhesives, obviously coatings. I don't want to go through every single one of them, but you can see them on the slide. And there is the new end-use markets. We hear a lot from people that are in the battery world. We're actually going to be at the battery conference in Orlando in 3 weeks, and then we have the one coming back up in, I think it's in September or October, up in Detroit, the large battery show up there, and we have our units on display. But many other end-use markets, cosmetics is another big one where they use that type of technology to reduce particle size. Okay, here's just a picture of a production environment, very clean-looking facility that is actually in Europe, at a customer. And here you can see we have the Dispermet SC production scale. This obviously you can purchase different container sizes, so they are more smaller containers for production. But the cool thing is that you can see right there the Dispermet SC with the quick change system can very quickly get converted over to a basket mill. So that changeover will take about 5 minutes, and you are seamlessly moving from a dissolver over to a basket mill. So this particular customer has a number of different machines, and in the middle you can see a dissolver, and right next to it the same thing configured as basket mills. And on the back here, same machine, but it's closed. So that's what it would look like when you're actually running the machine. It would come down and then basically look that way, as you can see there in the back. So the Dispermet SC is our dissolver for production. We have output anywhere from 15 to about 55 kilowatts. we can go up to 2,000 liters of slurry. So that would require a 2,500 liter container. We have different control panel options and the ability to configure it with that QCS, with that quick change system. That basically allows you then to attach basket mills onto the same machine, and or even a rotor stator, and run it not only as a dissolver but also as a fully fledged milling system. And then we offer this particular setup with the particular a cover system. It has basically a pneumatic valve cover for with the lift system, so you can actually lift up the cover independently from the shaft. That will allow you then to access the bottom of the cover for cleaning, which is also very important. So the cover will move independently from the shaft. Um, and then obviously we have systems like this that are also in vacuum. So some of the newer end use markets, they don't like any air. So they would prefer to have a dissolver that can take out any air or flush with argon or nitrogen. We also offer the option of a wall scraper system for this specific application, especially if the viscosities are really high or thixotropic, and you want to move the product in the container and always push it to the center where the dispersion wheel then will take over. But they're super cool when you see them, and do a really good job keeping the container wall always scraped clean and ensuring that all the product gets dispersed, not only part of it. And so that's an optional attachment. And then we have the explosion-proof models and the Dispermat SC as well. So this is something that we offer depending on the environment they go in. And then we offer also the vacuum, as I said, so that allows you then to pull the air out and flush with nitrogen or argon or any inert gas if you want to have that type of environment, or create a blanket of these type of environments. Okay, so here it's just a quick slide on explaining that setup with the quick change system. So basically, you would be purchasing a dissolver, and then with that quick change, with that QCS quick change system, you're then able to quickly remove the dissolver head shaft and then replace it with the basket mill. So that, or even a rotor stator. So that would be something that you could do in well under 5 minutes. And it allows you then to really go seamless between a dissolver and a basket mill. Don't need so much space. So there's a lot of advantages, right? So you would have only one piece of equipment really instead of multiple pieces, because what customers have been doing, so let's say you have a coatings operation and you have many different color families, and orders come in, and instead of you tying up a machine all day or half a day for cleaning, what you can do very simple is to remove the basket, do like a quick flush, and then you remove the basket, and then you replace it with the basket of the next color family that you're running. So that would then allow you to always utilize the equipment and not tied up for cleaning. So that's really, really helpful. And it also allows you to have very quick color changes. So go from, a white to a red or a green. It can be literally within 20 minutes you're up and running on your next color with a new container, and set that up. So there are many, many advantages. Also from a maintenance side, you only have really one piece of equipment to service, not multiple pieces of equipment. So that's a really, really nice way of running your production line or setting it up that way. So here's just a picture of the SC with the vacuum, when the cover is closed. So because we are removing the air, there is this idea, and we have seen it in our lab, that when we actually mill under vacuum, we're able to put in a little bit more energy, and it just increase the milling efficiency. So we're removing also any type of foam So that also allows you to transfer the product quicker from one container to another. But if you think about air bubbles inside of your mill base, they are almost like tiny little air mattresses, right? So they're little bubbles that are in there. And when you're milling, so the beads that try to basically break up these binding forces, they get swooshed around the slurry, and then with the mill base. And then if you have these air bubbles, right, little air mattresses in there, they almost cushion the blow of the beads, and that is a hindrance of what we call high milling efficiency. So if you remove that, you're improving the milling efficiency, and that will help you, produce a quicker dispersion, um, or quicker end result, and that helps you also save money, um, because you're just faster and more efficient. So there's different types of vacuum pumps that we offer depending on the container size. And then obviously some customers want to include that nitrogen purging valve that's included in the cover. And that's something that we can also build for you. That's a close-up of the cover. It's a really well-designed piece of engineering. So here, very tight lip seal. You have a viewing glass. There is actually a light, an LED light that you can turn on that will actually show you what's going on inside of the container while you're dispersing. And then we have extra feeding uh, ports, if you want to add more material, and then your valves to relieve pressure and or add any type of inert gas. So that what that looks like. We offer different types of control panels. So on the left is our high-end, we call it SC technology. That's actually born out of the laboratory environment where customers really want to track everything from the amount of energy they're putting in to the exact torque value, um, tip speed, temperature, time, and actually display a diagram where you can visually see all the dispersion parameters in a trend line, indicating exactly what is going on during the dispersion process. Um, it really was born out of the lab, environment, and then kind of progressed all the way up from pilot and then to manufacturing. So we have actually a number of customers now in a production environment that's very helpful to them to also understand how the batch is developing and how is the milling process progressing during the cycles. So here you can also store data, export it to lab, to an Excel for lab reports and so on. And then on the right, you can see the standard control panel, which is really kind of crude, but very functional. Always with safety in mind. That's our technology. Safety is always key. Just here an example, you would only be able to lower the container cover if you have both your hands on the uh, on the panel. So you would need to turn. You see those two knobs on the bottom right there. Uh, Basically start, stop, and then the up and down. In order for you to lower the cover, you would have to turn both of them clockwise. If you only have one hand on there, it will not do anything. You need to have both hands on the panel. Otherwise, you'll not be able to lower the container. That way, it's guaranteed that you won't squeeze your hand in between the container lip and the cover. So just some things like that that are really important that we have in place to ensure safety for the operator. And then here is just a programmable panel that we work with Siemens. So if you want to integrate it, the dissolvers or the basket mill setup into your overall workflow, production workflow, then that's something that you can acquire through us and then program it the way you want to use it with your workflow. That's just a quick picture of the pilot plant that we have in Germany. We are in the process of adding a smaller AE10, which is about, I would say mid-range of mid-range of our pilots machines up to Wallingford, where we also have a lab. and that will allow us to do about 25 liters of material. So more than lab, and definitely something that will be available to our customers and can show you how scalable the equipment really is. And then we have something really unique and very cool is some customers that are doing products that never worry about color change. So it's like we're doing the same thing all the time. We want to pre-disperse and then we want to mill. So with this machine, it's called the Dispermat TM. It's basically a 2-in-1. You don't have to add a basket mill to it, it's already there. So basically, you have a dissolver and basket mill combo. And by the push of a button, the basket will then come down and you would be able to do milling. So you can see picture 1 on the top left. You can see we're putting our mill base under the machine. Then we push a button and then the dissolver blade will come in. We're adding more raw materials. We are deagglomerating. We are wetting everything. We are doing properly mixing our slurry. And then on the bottom, you can see the color changed already. So everything is now properly mixed and pre-dispersed. And then at that point, we push a button on the panel and then the basket will come down and now we're actually milling. And that allows us then to really go down in particle size into the nano range if we have to. And then we are done. We just remove the container. And that's done on one machine in one location on one operation. So very, very cool, very easy to use. And we have a number of customers that really enjoy using that machine. So again, we can go up to 55 kilowatts. We have 1,600 liters of volume, a little bit less than on the regular dissolver because the mill head, the basket mill, has a lot of weight, and obviously that's why we, and also space, and that's why we had to go from 2,000 liters to 1,600 liters. But also again, different control options, explosion-proof models available. We offer also vacuum, and then for batteries or certain type of coatings, we offer ceramic components to ensure that there is no bleeding in from the steel or metal from the milling components into your slurry. So that's also something that is optional. Again, here's another picture. It's just kind of how it works with the TM. First, we pre-dispersed some material, and then obviously when we reach the right particle size, we start the milling process. The beauty is that I can use our TM in the lab and then scale it up to the TM in manufacturing very easily. So all of our equipment has one huge advantage is that it's very scalable. And that's really nice, developing something in the lab on a smaller scale like a TML1 or TML5 and then upscaling it to the large production machines. Also, very easy to clean or relatively easy to clean. Once you're done, you just remove the container. So containers can either be shipped with wheels or forklift channels or both. So some people prefer to use forklifts, especially in the very large containers. So that's also an option. And then you would just replace that container with another container and have some cleaning solution or water in the container, about 50% fill rate, and then you submerge the mill and run it for a few minutes, and then you rinse and repeat, and that will do a really good job cleaning it. So if you are not changing colors, you probably won't even have to open up the basket and drop out the beads, down the beads. You'll be able to do that, the flush, and you should be able to have a really good rinse that way. Okay. That is actually a customer that we have that has 2 Dispermats TM in operation. That was during the installation phase. So the cowls blade are actually leaning against the blue drum in the background there on the left. And then they're both exactly the identical machines, except that the one machine on the left is raised to the top because we put the container underneath. We're getting ready to actually run a product. And that customer right there, that's actually a 2,500 liter container. So you can see it's pretty large. And then the machine on the right hasn't been really assembled yet, and that's kind of its resting position. Or actually, when you're dispersing or milling, it'll come down, and then that would then be what it would look like when it's running with the container underneath. So really good machines, workhorses. They run 24/7. And we really haven't had any difficulties from a maintenance aspect, except because they're running the mills so often or so much that they had worn out milling. The standard milling disc was wearing down because of after a year of just nonstop milling. So they replaced those with ceramic, and we have not had or heard from the customer about any parts that needed to be replaced. So really, really good machines. And then we offer the Tourist Mill SK. So it's the exact same machine as the Dissolver SC, except it comes shipped with the basket mill on it. And here you can obviously also order the quick change system. It's just a different flange that we install. And then that allows you to also go back and forth between a dissolver to a basket mill. But in this case, it's configured as a standalone basket mill. Again, vacuum option exists. We can swap the baskets very quickly with the quick change. And then because we're running a basket mill, our maximum volume is 1,600 liters. And then again, ceramic parts are also optional. Especially, if you're doing a lot of white colors, and you probably already know that, the stainless steel of the mill eventually during the milling process, because milling is very abrasive. The beads will impact the sidewall of the inner sidewall of the mill, and that would then cause some of the steel or the iron particles to drop into your slurry. So what we have seen through it with some customers where they have an extended milling time, that a white material would turn almost gray if they don't use ceramic parts. So that's something that you might want to consider if you're running white products, or electrolytes for like batteries, where any type of metal is an absolute no-go, or fuel cell applications. So that is definitely something that you want to look at, and we offer those options. And that's kind of the way that we go about changing over from a basket mill to a dissolver head, is by using these trolleys, these transport trolleys. So they're very easy to move around. So they got the handles on them, and then you just put the trolley underneath the machine. Obviously, the container would be removed from there, and then you drop down either the dissolver or the basket, and then you basically line it up. One person can do it, no problem, and you can do that changeover in less than 5 minutes. So very, very easy. There's only one cable that you really need to unplug, and that's the power cable, and that's it on the cover. So nothing else really that you need to worry about. So that's kind of like just a quick photo on the SK, self-explanatory. Put your container, the pre-dispersed material, in this case, under the basket, lower the basket, do your milling, and then you're done. And this is kind of a graph of our basket mill design. So some of you may heard or have been using immersion mills from some other manufacturers, and they have screens on the side wall of the basket. Maybe you have a slide here where you can see that better. Yes. So, sorry, I'll go back. So here you can see that wall right there, the side wall on our basket is closed, right? Our screen is actually on the bottom. So if you can look at that graph, you'll see that the screen is on the bottom. The reason is that when we are milling, that milling disc will basically throw these beads around the milling chamber with very, very high force. And if we have a screen right there on the side, that those beads will impact the screen nonstop. And that will lead to very high screen wear. And that means you'll have to replace your screen all the time. By having the screen on the bottom, we have seen that the screen wear is reduced to a minimum. So that's one huge advantage. A much bigger advantage we find is cooling. So all of our basket mills, except the very small TML05 for the lab, tiny one, all of them have cooling capabilities. So with the basket mill, we actually have these bars that hold the basket here on the left and right, and there's one in the back. So there's 3 bars. So the bars right there in the front, they actually have cooling lines going through them. And the baskets are actually double walled. That means that the cooling fluid will run through the entire basket, even the top portion, and ensure optimum cooling of the mill base in the baskets where we are putting in all the energy. So that's where I need to cool. And we are able to actually measure the temperature with the PT100 probe that's installed in that bar behind that you can hardly see. It's behind the bar on the right. There's another bar in the back. The third bar that's holding the basket in place, and that's where we actually have a PT100 probe, and that actually measures the temperature inside of the basket. So very important, optimum cooling is critical, and our design is different for optimum cooling and for reduced screen wear. So it's very, very important to understand that when you're looking at mill designs. And we can talk to you more, and I can show in person if you are at the European Coating Show or you're coming up to our lab in Wallingford, then we can discuss it in more detail. Then we also offer a whole line of horizontal mills. That's the RS for production. The smaller family member would be the SL for the lab. And then we scale it up to the RS. So we can do about 1,000 liters per hour, all the way up from 25 liters. And again, ceramic parts are optional. We can mill down all the way into the very low nano range. We also have a vacuum option and different control capabilities of the RS mill. APS system is what I mentioned very early on. That is another milling system. It's basically a vertical bead mill. Some people refer to it also as a pot mill. It's an excellent milling solution for the lab space and small pilot because it's very easy to handle, right? So you can use a standard dissolver. You basically have 2 containers. You have a top container that holds your mill base or slurry. You pre-disperse in that container, and then when you're ready to do milling, you just remove the cowls blade and you replace it, as you can see in this case, with a triple mill head, and then you add your beads to the slurry. And then you basically close the cover. There is a lip, there's a seal, and then you have a clamping ring that goes around it, and you're basically then milling inside of the container. And when you're done with your milling cycle, you would actually hook up an air hose. There's an air socket in the cover, and you hook up an air hose and you will pressurize the APS container, put it under pressure, and then you can remove. There's a drain plug on the bottom. And then you can see there is another container that's right below, and you're actually flushing your material or purging it out with air pressure into the container below. And the beads will stay behind because there's a screen that is inserted right in the middle. So right above the drain plug, we have a very nice screen with different mesh sizes. So depending on the media that you want to use, we can go down to very, very small mesh size. I think 0.1 or even 0.01 millimeter ultra fine mesh size for using very, very small beads and ultra fine milling requirements. So we can use 0.1 millimeter beads with the finest screen that we offer. And that is very cool. But the dilemma here is we can't really use it for manufacturing because if you imagine building something like this for even 1,000 liters, I mean, you would use enormous amount of beads. So the bead handling would be problematic. Also, the expense of buying so many beads, right? I can put 100% of beads ratio to my slurry ratio in here. So if I have 100 milliliter of slurry, I can add 100 milliliters of beads, which is really awesome because I can do a lot of milling um, with um, with very quick milling with that many beads. Uh, but in the laboratory, easy to handle, no problem. But as we go up in size, it becomes a lot more expensive and tricky for the bead handling issue. Quick picture here. That's our lab in Germany. Very well equipped. We got a lot of good stuff there. Vacuum system, basket mills, rotor stator, and the upscale lab below. So if you're over there, there's also a horizontal mill we have, nano kit. So it's really nice to go there and just run trials or just look at the equipment. And then we have also a super well equipped. We're going to update this picture. Come March, we're going to have a lot more equipment in there. We're going to get a vacuum system, a VL unit. We have the horizontal mill back that's out on loan. We have a new CB3 Evo, which is the brand new awesome laboratory scale dissolver for best upscale performance on the market. Allows you to do milling. Use it as a with a vertical bead mill and APS. You can put a rotor stator on there. So it's a really cool small machine. Go on our website, check it out, and it's available now. And there's two versions. One will have a scale with it, the advanced version. And then we have the AE up there with the C control panel for scaling, so we can play around with that and show you that technology. And then obviously horizontal mill as well. So we would love to have you up there and tie you in with our colleagues at Big Additives who will be supporting any type of project in the lab. So that's one big advantage of when you work with a company like ours, and you would go and buy a Dispermat solution for your manufacturing environment or lab space. We have really good resources with our additives group. And we have customers that come into the lab with a problem. And hey, we need a new dispersion, or we have issues with that. We can work on that with you and then make recommendations and say, hey, this solution, that additive package works really well with our dissolver or milling technology. We have proven it out. We can show you in the lab and then help you upscale that to manufacturing. So I don't know of any other company out there that offers that much synergy between an additive supplier and their equipment. So we're really the only one that optimizes the equipment to the additives and vice versa. So we can be a really good resource for both angles. And if you just want to come up there and look at the equipment without running trials, that's fine too. Or just come and call us. We'll bring you or your team in, and we can do even a seminar up there for you and have you learn more about the process. So that's definitely something we would like to have. So thank you very much.
Yeah, good stuff, Andy. As always, thank you for sharing your expertise with us. We do have a couple questions, and we have a few minutes left, so this is perfect. Question here: when we use organic pigment and inorganic pigments, we have a phenomenon of shading. Is that due to a dispersing agent that can give the good results? That might be more of a question for our sister company. But
Yeah, I think definitely it's shading could be definitely an issue, dispersant related. Um, I would say milling. I would look at particle size. compare two different lots where you see more of shading versus the other one, what that looks like. But it's hard to say, over the phone. We need a little bit more information.
Okay.
But shoot me an email, and then we can maybe set something up, and at least a Teams call with my colleagues, discuss it, or have you come up to the lab, and we can run your material on our equipment and look at different solutions.
Great. And Andy makes a good point too. If after the fact, next week, later this week, you have a question, you can simply hit reply to any of the marketing messages you get, and it'll come to my team, and I'll funnel it to Andy and his team to get back in touch with you and get those questions answered. Another question here: does the diameter of the bead have an impact in milling and grinding?
Absolutely. So bead diameter plays a big role. It's bead size basically, but it would then obviously depend on the particle size that we're starting with. So as we are milling down, we would then progressively also reduce the diameter of our beads. I have a presentation actually on milling. So if the person that asked the question would want to join that, or go online, there's on YouTube, maybe John, you want to post a link about the milling part, and describes it kind of why that is, why we need to reduce our diameter of our mill, of our beads, the smaller we get. But what's more critical than sorry, John.
No, go ahead.
So what's more critical than the diameter is actually the kinetic energy that we're producing with our beads. So it's the bead material. So we still talk to customers that are like, we're using glass beads, we cannot get proper dispersion out of our, with our material. Very simple. They don't have enough energy to break up these aggregates. And the reason is the glass beads are very light compared to a zirconium oxide bead. So they're 3 times heavier. And that means that you put in a lot more energy into your mill base when you're actually milling. So it's a lot of milling performance comes down to how energy that you're putting into the mill base, and that's the bead weight is plays a heavy role in that calculation.
Thank you. And to your point, we do have in the chat, I put a link to our Dispersion YouTube channel. So in there, you can see different videos, recordings of previous webinars like this. Like Andy mentioned, we have a deep dive into milling, a deep dive into the dispersion process, a whole lot of other things. You can check out past things. We're also planning on doing some new videos. So those will be coming in the next couple months. So stay tuned there. A question, can you talk about the cleaning step at the end of operation? They're asking to show it, but I
can't really
video.
show it. It's gonna be, there will be a video, but I can tell you what we do. So in production, basically on a basket mill approach, it depends if you have a TM where the basket is integrated. It's not easy to remove, right? If you have the quick change system, what we do is very simple. So after we're done with our milling cycle, I would basically lift up the basket just above the mill base in the container, and then from there I would then run the mill a couple minutes just to remove any excess material inside of the mill and let it drip down to my mill base, because it's good product. If there is nothing coming out anymore, I then would take a rag and wipe the bottom of the screen on the bottom of the mill where the material comes out. If there is no more material or it's pretty clean, I would then remove the container or remove the container before, because you don't want any lint in there. and from the rag. And then you have another container you will put underneath with the cleaning solution, solvent or water or whatever you want to use. And then I wipe down the mill from the outside and then drop it into my container or drum with the cleaning solution. And then I run it for a few minutes. And then usually what I do is I lift it up and then I rinse through it. I kind of cycle through the mill itself from the top down with clean water and kind of clean it out that way. And then once I do 2 or 3 cycles, the mill should be pretty clean. And then I remove that container, and then I usually I'm good to go for my next batch. Or if I have to do a color change, I will then open up the screen, the screws on the bottom, drop the beads down into a tray, and then clean that a little bit more thorough with a sonic bath, and then put the screen back on there, put new beads in while I dry the other beads or clean them, and then I'm good to go. But much cleaner and more efficient than a horizontal mill, night and day.
Yeah, and quicker.
Way quicker. Yeah. Like we have customers that love the quick change system because it saves them so much time and money. I mean, going from one color family to another without tying the machine up for cleaning for long periods is gold, so.
Yeah, anytime those machines aren't working, you're not making money. So this is
right.
This is a great solution. Another question here about dust management. During the initial mixing process, should there be dust extraction or absorption system in place, or does ours include that, or can you talk a little bit about that?
Yeah, so we don't include that. Basically, there are filtration companies that offer these type of solutions. What we tell our customers, at the point of, where you install the equipment, what we have seen is usually customers have some type of snorkel that they can bring down from the top. They hand pull it down, and then they would then add the material with the snorkel pulled down, and that would remove any type of dust that's floating around in the air. Nice. Or we have some customers that want to do everything without air exposure at all. So these covers are designed that you can actually hook up a hose, a product transfer hose, and then you would have an area where you have your product and then transfer it into the container while the cover is closed. So that's also something that we can work with.
Nice. Okay, another question here. Is this kind of milling appropriate for vinyl plastisols?
It could be. I mean, it depends. We would need to know a little bit more about the makeup formula. It's basically the type of milling that we're talking here is not really. It's not so much impact milling, but it's really more like breaking up binding forces, like these particles that are stick together. That's invisible forces. So a lot of people think we are actually crushing pigments or particles. It's not really what's going on. It's really just separating these binding forces. Yes, there is some destructive milling going on for sure, but that is not really the goal or the point of this type of equipment, So it really depends on what it looks like and what particle size you're looking for.
Okay. Yeah, Frank, if this is, want us to take a look at what you're actually doing, feel free to reply to an email or marketing message, and we can go from there and learn more about your process.
And all this is wet grinding, right? And wet milling. So we don't do anything dry. Everything, all of our equipment is for wet milling, wet dispersing.
Yeah. Good. And Andy, hope you didn't mind. I just put your email address in the chat here. So if anyone has any questions, they can contact Andy directly. Other
Please do.
questions? Yeah. Oh, you're welcome, Tafai. Other questions? We might have time for one more question. If anyone wants to get one in. Otherwise, Andy, what's the, I guess, the overall thing people should look for when they're either using an existing dispersion system or looking to upgrade their technology, and based on what new innovations are available today?
Yeah, I'm interested. If you don't have a lot of experience with basket milling using horizontal mills, three-roll mills is what we see a lot of still out in the field. And I can tell you from my personal experience, it's pretty amazing when we have customers that come in to our lab and they're wondering if a basket mill can do the job that a three-roll mill can do. And for years ago, when I was been with the company for 20 years, I wasn't sure myself. But now I can tell you it's night and day. I mean, we have customers that are using a three-roll mill for some yellow pigment, and they're milling this, and one was a maroon color for, I think it was 14 hours straight. So the guy calls me up and he's like, "Hey, I'm interested in your basket mill technology. We are using a three-roll mill. It takes us 14 hours. It's a long process. Do you think that we can reduce the time in half when we use your basket mill?" I'm like, "Yeah, well, let's take a look at it." I didn't promise him anything, but I said, "Come to the lab, and then we take a look at it with your pigment." We were done in an hour and 20 minutes with both colors.
Wow.
Yes.
That's huge.
Yep. Yep. So I mean that he called his boss up, and a week later we had an order. I mean, there is no more. What else do you need to justify purchasing that type of equipment? So, and it's a lot safer to use than a three-roll mill.
You're saving a whole bunch of time. You're saving with the quick change. For cleaning, things like that. It's just really an incredible technology.
Yeah, and the equipment is nice. We have direct drive. Our motors, they don't have any belts. There is no, maintenance really. You don't need to grease anything. There is no air. You don't need to run the machine or it's all hydraulics. It's all electric. It's all enclosed. Really they're maintenance free pretty much. And also they're extremely quiet. If you ever worked with the Dispermat, you would know how quiet they are, but they're definitely the quietest machines on the market with the least amount of vibration. I mean, it's a quality product. We are not the cheapest ones out there, but you will also be able to get great service, get parts when you need them, and have somebody on site to address your problems in a timely fashion and ensure that you're always up and running. That is the most important thing. It does nobody any good to go on a budget and buy some inexpensive basket mill technology from wherever they come from now, and then you need a part, and then the email doesn't work or the phone number is disconnected. We get calls like that every day, where people they buy cheap and then they can't get service. So yeah, you pay a little more, but you get a super quality product.
Yeah, absolutely. All right. Well, thank you everyone for the great questions. Thank you, Andy, for your expertise as always. I'm always learning stuff on my end from you, so thank you. Again, you'll get a link to this recording. Feel free to share it with colleagues, listen to it later, use it for date night, whatever you like. And then, and two, if you have any questions after the fact, just hit reply to any of the marketing messages you get, and we'll route it to the right people. But thank you for attending our Dispersion Innovations webinar. Stay tuned. We got a deep dive into dispersion, deep dive into milling, and a couple other things coming. So watch your inbox. You'll be sure to be invited to those. So with that, have a great rest of your day, and thank you. Happy dispersing.
Thank you, everybody.